It's great to see so many people have turned up to this event, and I'm really looking forward to demonstrating what Flood Platform is. And the benefits it can bring. Just to give you an overview, in this webinar, I'll be talking about our ambition, our mission in developing Flood Platform. I'll be looking at some of the key challenges faced by the flood risk management community and how Flood Platform responds to these challenges. I'll also give you an overview of the functionality we're introducing with Flood Platform and how to support you to deliver work, to do your work more efficiently, more effectively, and make modelling more enjoyable. Towards the end of the presentation, as Chris says, we'll have time for Q&A. If anything occurs to you during the presentation, please feel free to drop a question into the question section on the GoToWebinar interface. So what's our mission? So with Flood Platform, our drive is to unify flood modelling, providing a platform that empowers modelers, engineers, stakeholders, clients to collaborate, to optimise their solutions that address the challenges of climate change and flood risk. This builds on Jacob's decades of experience in providing flood risk management services and a deep understanding of the challenges faced by practitioners and suppliers, combined with the growing need for our services. There's an ever-increasing need for the services we provide as consultants, as flood risk management organisations, and really we need to drive change in order to meet these challenges. Flood Platform has been designed using Jacob's extensive experience of flood risk management across the globe, as well as our product development capability, things like Flood Modeler. And this has been combined with extensive research into practitioner needs. What do people really need? So when we designed Flood Platform, we have asked across the industry, what are your biggest pains? What are your challenges? As well as what your vision for the future of flood modelling can look like. And we've asked a wide range of people these questions. We've covered users from all different disciplines, practitioners, stakeholders, clients, with different backgrounds and from different geographies. And we've received remarkably consistent feedback across all those we've asked. And we'll divide those into sort of 4 broad themes. And I suspect none of these are going to come to a surprise to anyone. The first challenge and opportunity is around collaboration. Really, collaboration is essential to achieving the best outcomes in flood risk management and flood modelling, providing team members within your organisation, colleagues, partner organisations and clients access to models in a seamless way. This allows them to provide comments, undertake reviews, and generally improve the quality of our models, but is often stifled by the size and complexity of our models. So we're generating models which are hundreds of gigabytes, terabytes in size now with all the results, and the tools available struggle to transfer that information quickly between partners, between organisations, reducing the amount of collaboration. So when we talk about collaboration, we want to make it easier to share models between users, to review models and provide feedback on them in a meaningful way, so less getting back to Word documents or Excel documents with lists and lists of comments. And as well as sharing the models, we also want to be able to share deliverables, reporting, model logs, model passports, and so on, and to develop these faster and integrate them with the models. We also want to be able to share best practice. Teams from across organisations are coming up with new ways of working, and we want to be able to share those effectively between users. Data, no surprise, I'm sure the bane of every modeller's life, and certainly IT organisations who support modelers' life, is data. Within Jacobs, our internal modelers are generating terabytes of data each month for fluvial modelling alone. And we've got to store that data somewhere, so we need to find a place where we can store that data. And traditional internal file servers are really struggling with the size of data we're generating. And once that data is stored, it's a challenge to transfer it within an organisation and to external users, going back to that collaboration piece. A real challenge I see we face is around managing that data as well. So once we've built those models, we've got all those files, all those components, how do we control the versions around those? How do we know which bit of the model is which? And certainly I've gone back to models, a few years after they've been built to try and work out what's going on. It can sometimes be an absolute struggle to work out and make sure I've got the right version of any given file or any set of results. They're also challenged around visualizing that data. So it's, looking just at a fairly bland Windows hierarchy of files is not very informative. We want different ways of visualizing our data, both the input data, so the spatial data that goes into your model, the LiDAR, the active area, and so on, but also the results as well. If I want to look at results from old models or work someone else has done, I don't have to be able to download those to my desktop and have to upload them into GIS software or Flood Modeler or HEC-RAS. I want to be able to visualize those all in one place. Tied to all this is the ability to apply data analytics, data science, machine learning, and other tools. Really, I'll talk about this in a bit more detail a bit later on, but really we can see the advantage of these tools, but the way we store our data isn't sufficiently structured or consistent to allow us to deploy these tools efficiently. And finally, at the end of projects, we've created these massive data sets. They can't live on our servers as live project data forever. They need to be archived, and this presents its own challenges, both archiving off that data effectively, and then if we do need to recover it in months or years' time, be able to bring that back into a live system. And I know lots of people still use things like external hard drives to store these archive models, which is suboptimal from a data resilience and accessibility perspective. Technology. We've seen major shifts in technology over the last 5 years, particularly in the realms of machine learning, AI, and data science. We've still got some fantastic tools out there, and I'm sure many people can see the opportunities these can bring to make our work more efficient and provide better outcomes, whether that be automating tasks we do manually at the moment, fixing problematic models, getting things right first time. So by automating, standardizing these things, we avoid error and therefore avoid rework. And all these things can be done. We also want to use these tools when we come to optimize models. By that I mean verifying models, calibrating models, making sure they fit the observed data or expected data, and also optimizing solutions. If we're building flood walls, if we're building flood defenses or reservoirs, by having these tools, we can better optimize what we're building, potentially providing massive efficiency gains and cost savings. Linked to all this is the big challenge of simulations. We've been, years ago, we were asked to run models tens, dozens of times maybe. We're now into hundreds, if not thousands, of simulations for a given model. And it's an increasing challenge to manage all those simulations, both the licensing to do it. So if you've got paid for software, managing your license availability, but also the computational resource. You can't just run it on one computer and leave that running for days, weeks, years. We need a way of managing simulations spread across multiple computers, across multiple computational resources. And overarching all that is security. This data we're producing is sensitive, it's commercial in many cases, and we need really good access control. You need to have confidence only the right people can see your data. We need to be able to enforce policies and provide evidence and ensuring we're compliant with both our organization's security policy as well as our clients' security needs. This is where Flood Platforms come from. So Flood Platform is a tool that Jake has been using internally for the best part of 15 years. It's been used on everything from small-scale flood risk assessments through to flood mapping entire countries. And it allows us to manage all our modeling data from across all our users across the globe, to pool our computational resource, our licensing resource, as well as automate many of the processes, tools, and workflows we need to go through. We're now bringing that as a tool that anyone can use. So we're releasing this as a commercial product later on this year, so everyone can have access to that functionality. Out of the box, Flood Platform will work with a range of solvers. So starting off, that'll be Flood Modeler, TUFLOW, HEC-RAS, and SWIM. And we're already working with partners to add additional solvers into Flood Platform. And hopefully we'll have more to add in very soon. Under Flood Platform, there'll be several core features, and I'll talk in a bit more detail about these later. But they're generally under the heading of model management. So that's dealing with all that data, all those files, managing the version control, managing which file is which, who creates it, where it came from, and also providing that security as well. Visualization is a huge part of Flood Platform. You'll be able to visualize not only your model components, your 1D model elements, your cross sections, your 2D domains, But you'll also be able to visualize your model results, both 1D and 2D within the browser, and I'll show you what that looks like. Simulation and analysis. So Flood Platform is designed around being able to run hundreds, thousands of models in parallel across cloud compute resources. And this is really where it evolved from within Jacobs, the need to be able to run thousands of models effectively, quickly, and manage and track those simulations. So that's a big part of what Flood Platform does. If you do need to run these many simulations, you can do that easily with a minimal setup, and also undertake analysis as you go to tracking the simulations. A core thing, which I'm really excited about, is the collaboration aspect. So once you've run your models, once you've built your models, you can collaborate seamlessly, both with people within your organization, partners, clients, stakeholders, other interested parties. And this allows you to share those models in a really easy way. So no more sort of having to find all the model files, put them on a hard drive, and then ship them to someone, or share them by SharePoint or other means. Seamlessly be able to just choose an email address and click, and you can share those model results with other people. Model reporting I touched on earlier, so this is deliverables. So once you've got your model, you've also got things like model logs, model reports, analyses. Because we're holding data in a structured, categorized way, it makes it far easier to automate production of these other deliverables, starting off with quite simple things like logs and building to more and more complex reporting, again, bringing efficiency and consistency to your work. And then as security and compliance, you've got highly granular control over who can see what within Flood Platform, down to project, user, item control over what can be seen. This gives you far more confidence that your data is secure and that the right people are working it, and only the right people can see it. So Flood Platform is an entirely cloud-based service, which is accessed via a website, and so it digitizes these model build, management, and workflow elements. On this graphic, I'm giving you a high-level overview of how Flood Platform works. All users enter the system via a secure gateway, providing robust security and permissions management. And by default, that uses two-factor authentication to ensure that the right users are accessing the system. And that can be model creators, stakeholders, or clients can all connect to the same gateway. I'll show you that in a second. Once you're connected, users have access to a range of tools, and they're all listed here, so I'll pick out a few of them. You've got the ability to upload your existing models and results and manage those models in terms of version control, branching, forking, and so on. You've got simulation build tools to be able to build those thousands of simulations in an automated way, so fewer manual generation of simulation files, and then the ability to run those simulations using those elastic cloud resources, so you can expand those resources to meet your needs. We're building in a lot of tools to allow model calibration, uncertainty analysis, probabilistic analysis, and design automation, again, making use of that structured data environment. And the ability to view your results online. So via a web browser, you can view your results both in a tabular mode, also in a spatial mode, see your floodplains expand and contract in 2D, look at the time series results, the maximum water levels, and so on. We're building in model checking and quality assurance tools, which allow you to ensure your models are right first time. And that's both the model build element, so are my input files right, and also are my results right. We can scan for these results and look for common errors and aggregate those. What was my mass balance across all my models? Is my 100-year flood outline bigger than my 75-year flood outline, which is bigger than my 50-year flood outline? All these sorts of checks can be automated, giving you confidence in results. I've mentioned the report builder tools to generate things like model logs, and also the ability to share and transfer models between users, clients, and gain feedback and comment from those as well in line. All this is underpinned by extensive data storage. This is all cloud-based, so it's robust, secure, and scalable to meet your needs. You're never going to find that sort of running out of storage problem again. These automations, where we can see design and workflow automations, we're going to implement those to make your life easier, to remove those manual burdensome tasks and allow you to focus on making sure the model quality is good. The modeling applications I've mentioned are Flood Modeler, HEC-RAS, EPA Swim, and TUFLOW. They're coming out the box, and we'll add more as we go along. A key component is the compute, both CPU and GPU, depending on your solver, and that's elastic to meet your needs, and a growing ability to undertake machine learning and AI analysis of your results, and also using these tools to interrogate your data in more intuitive ways. Just having a look at what the system looks like. When you first land on the Flood platform website, you'll be asked to log on. This uses two-factor authentication by default and can also support single sign-on. So if you're a large organization, you can unify your credentials. This prevents people accessing the data who shouldn't, and also gives you full control over which user can access what. Once you're logged on to Flood Platform, we've got a very visual way of understanding your models and your data. So at the top level, when you log on, you'll see your workspace area. And workspaces are a way of grouping projects or models together. So a workspace could be for a particular client. You can have all your projects for one client under a workspace. You can have all the projects delivered by one team under a workspace, or in one geography, for instance. So these are really flexible ways of grouping together your projects. And these allow you to also control missions as well. So when you first set up a workspace, you can set up a spatial area in which it belongs. So it could be in England, Scotland, Wales, a part of Australia, a state in the US. So you can the geofence around that area. That's where you're working. And it helps you quickly track down where your model files are. You can provide project codes, permissions, management, and specify which users can access it and what they can do. Under each of these workspaces are projects, and projects again are flexible. These could be individual sites you're looking at, or they could be individual commissions. And again, you can put a geofence around those. You specify where these projects are, so it makes it a lot easier to find them in the future. And again, you've got that granular control over who can access the data under each project. Once you've set up your projects, you can start doing your modeling. So that maybe you've got a model you've been provided by a client. So maybe, say in England, you're doing a flood map challenge and the Environment Agency have given you a model as a zip folder, or it may be something you're working on already. And this is really nice. You can literally just drag and drop these files up into Flood Platform. And we've tested a range of file sizes from more reasonable up to absolutely ginormous models, and the system is handling it very nicely. And this is the first really clever thing that Flood Platform does. When you upload that zip file, it's scanned as it goes. So it's uploading the file, it's scanning the file, it's identifying all the simulations within that folder. So it's a flood modeler simulation. It'll be identifying batch files, IEF files, and SIM files. Similarly for TUFLOW, identifying all those TCF files. And it's validating each one of those. Once you identify those simulations, the software automatically tracks back all the files that form part of that model and validates them, identifying whether we've got missing files or inconsistent files and presenting that back to the user. This alone provides a massive time saving all the time to sort of track through model files. You know it's all in there, and if there's something missing, it's highlighted and the user is given the ability to replace it or upload the missing components. Once the simulations are uploaded and classified, you can start to sort them and work with them. So here we see all the simulations for a given project are uploaded. You've got the names of those, you'll have version control, but you'll also be able to put metadata on them, things like the scenario type, is it defended, undefended, with scheme, do minimum, do nothing, what return period is it, what climate change you've got, what storm duration. And where possible, we'll automatically detect as much of this information directly from the model files as we can. So we can detect from the name of the simulation or the input data what sort of simulation it is, and automatically populate a lot of this. Of course, the user can always override it or add more details if they need to. It starts to classify models in a more consistent way, making it easier to manage and navigate through all these simulations. If these simulations have been run already, you can jump straight into the results, which I'll show you in a second. But if you need to run them, you can do that within Flood Platform. You can simply choose the simulations you need to run and press go. The software behind the scenes, invisibly to the user, will spin up virtual machines to run these in the cloud, and as many machines as needed will be spun up and processed. And whilst those simulations are running, we're tracking progress. So you get instant feedback on how far through those simulations are. So you've set up 10, 100, 1,000 simulations, you can track their progress. See the ones that are complete, see the ones that are in flight, as well as see the ones that potentially failed or got issues, allowing to stop or interject and start fixing problems. There's a really one-stop shop to see what's going on with your simulations. Once your simulations are complete or you've uploaded existing results, you can visualize them all within Flood Platform. This is great. You can see your 1D, your 2D results in a web browser against background mapping or other contextual data. So you can animate through your time steps, your 2D model, see your time series plots, compare different results, see maps and outlines all here. You don't need to download the results to use your desktop app. And this is really powerful, particularly for partners, clients, and stakeholders who perhaps don't have access to the right software or perhaps don't have the expertise. They can very quickly visualize their data without having to download it or interpret it. So you can imagine if you're sharing your data internally with an engineer or a flood risk manager who doesn't necessarily want to be able to get into the nitty-gritty of the software, they can quickly access their data and share that and use that in their project work. Combined with the visualization, we've got dashboards which allow you to track progress of models and simulations, and these are adaptable, so you can change these to look at, by user, by project, by workspace, how much data is being held, how many simulations are ongoing, how much compute is being used, what's the status of the models in terms of QA. These are really flexible dashboards which allow you to better manage and visualize what's going on in your projects and manage your modeling across organizations. Combined with this, we've got our reporting tools, our deliverable tools. These will start off quite basic, things like model logs, but as we've got the structure and the classification of your data, we can start to create more and more complex outputs like model reports, model passport files, input statements. These can draw on model components to generate elements within your reporting. That could be flood maps, that could be lists of input data, where your data came from. Because we're gathering that metadata, or you're providing that metadata as the simulations are run and uploaded, it allows you to access them quickly and provide consistent reporting a lot faster, bringing huge efficiencies. And this ties into what we're doing in Hydrology Plus with Flood Modeler around generating standardized reports and using user data. This is going to be a massive efficiency saving. Collaboration, as I said, is really important. So once you've got your model data, you can share it with other people. So that could be sharing it with someone else in your team, or sharing it with a client or a stakeholder, a local authority or a developer. You can simply just choose what you want to share, which simulations, click share, provide an email address, and off it goes. And that user can then jump in and see this. They'll be able to, depending on what you've given them permission to do, see the same level of detail as you, or higher level, perhaps if there's, say, a community group who just want a high level overview of this. And they'll also be able to provide inline comments and spatial comments. So you'll be able to click where they think a flood map isn't correct or a model setup isn't quite correct. And these inline comments are a lot more useful than receiving sort of spreadsheets or emails with comments and feedback. They're embedded and they're also inline, so you can respond and provide that feedback loop, whether that's doing internal QA reviews or external validation of your work. And I think this will save a huge amount of time. This also sort of ties into your model sharing. So at the end of your project, when you're looking to share your model with your client or hand the model over, this simplifies the whole process. Rather than download data, just make sure you've got all the right files, stick it on a hard drive, or share it as a massive zip file somehow. It's simply a matter of choosing what you want to share, choosing the deliverables, and then sending it to your client or end user. So Flood Platform is still in development. We're looking to launch a beta trial of this towards the end of the summer. And if you're interested in trying this, if you go to our Flood Platform website, www.floodplatform.com, you can click the register for trial button, fill in this information. We'll drop you an email when the trial and the beta is ready. And this will really get you hands-on with the software, see what it can do. And we want feedback. We're really keen to get as many people using this as possible, so we get some feedback on it, so we can make the release version later on this year as good as possible. And we're looking to launch this in October, November time, so back end of the year as a fully functional product. I hope that's been useful, giving you a high-level overview of what Flood Platform can do and what our aspirations for it are.